Hello, I'm about to do a problem about proton entering a potential difference of 500 volts across the electrodes, and the electrodes are 5 cm long parallel and they are 1 cm apart. We're about to calculate the strength of the magnetic field that will allow the proton to go through it undeflected. So as we know, the force on a proton is F equals QE, where Q is the charge of the proton and E is the electric field. Now the magnetic force on a proton equals F equals QVB, where Q is the charge of the proton, V is the velocity with which proton is moving, and B is the magnetic field. In our cross field, where we have both magnetic and electric force, the forces balance each other. That's how the proton moves through it undeflected. Force magnetic is QVB and force electric is QE. So once we cancel the Q's, we get B, which is equal to E by V, where this V is the velocity of the proton. As we know, electric field, which is equal to potential difference over the distance. The distance between the electrodes was 1 centimeters. When we convert it, it becomes 1 × 10⁻⁻2 meters. And once we plug it back here, we get 5 × 10⁴ volts per meter. Now, suppose in the absence of magnetic field, the proton beam only experiences electric force. So electric force equals F net. F net, as we know from Newton's second law, equals ma. So QE equals ma. Then we can calculate the acceleration of that proton, which is QE over m, which calculated to give 8.7 × 10⁻15 meters per second square. Now, plugging this acceleration into kinematic equations, we know the proton was in the middle of the electrode, so it was a displacement of 0.5 × 10⁻⁻2 meters in the y direction. Velocity initial was 0. And we just calculate the acceleration, and then we can calculate the time taken for that proton to cross the electrode. Now in the x direction, we know velocity is change in distance over change in time. We just calculated change in time, and using that we get change in distance, which was 5 × 10⁻⁻2. We can get the velocity, which was calculated to be 1.0937 × 10⁻⁶ meters per second. Plugging this velocity back into the original equation, where B equals E by V, we can calculate the magnetic field, which is 45.71 millitesla. Thank you.